We are going to continue our lessons on how to simplify polynomials. First, let's start with addition. Let's say we have 4x3 plus x2 plus 2x plus 3, and the second polynomial is 3x2 plus 5x. We have two ways to do that. First way is best to group like terms together and get rid of parentheses, then simplify the polynomials. So we regroup them, start with the highest exponent, 4x3 plus, then we have x2 here in the first polynomial and 1 in the second polynomial, and we put 3x2, then we have x to the first power plus 2x. There is another one on the second polynomial, which is 5x, and 3 comes last. Now we don't have parentheses. We can add like terms together and get the sum of them. So we'll have 4x3 plus x2 and 3x2 together will have 4x2 plus 2x and 5x is 7x plus 3. And now we are done. It's simplified. The second way is very much similar to the method we use with the numbers. Just like with several place numbers, we add them vertically and we treat the powers of the variables like place values and line up the like terms. In that case, we have 4x3 plus x2 plus 2x plus 3. And the second one has 3x2. We line it under the x2, so we'll have 3x2 and we have plus 5x. Then we add them up, bring down plus 3, positive 3, and positive 2x plus positive 5x is positive 7x. Then we have positive x2 and positive 3x2. We have positive 4x2 and we have 4x3. We have the same result as the other way. Just remember, getting the sum of something, sum of two numbers, and the second is to have the product of two numbers. When you are talking about sum of two numbers, you are talking about addition. When you are talking about product of two numbers, you are talking about multiplication. Right? So when you have x plus x, in fact you have 2x. When you have x times x, you have x to the second power. This is very crucial when you are adding or subtracting polynomials. Mostly people get confused with these two concepts. But remember, sum of two numbers, sum of two variables is 2x. We add them up. When you have multiplication, you get the product of two variables. Therefore, you multiply them and you get x to the second power. Now let's simplify one example in subtraction. Let's say we have parenthesis 3x2 minus 5x minus 9 minus 4x3 minus 5x2 minus x minus 3. First, we need to drop parentheses. So we'll have 3x2 minus 5x minus 9. We have a minus sign in front of the parentheses. In order to get rid of that sign, we need to make sure to multiply it to all the terms inside the parentheses. You can see it as minus 1 because minus 1 multiplied by any number would change the sign, not the number. So we multiply minus 1 by minus 4x3, we'll get minus 4x3. Minus 1 times minus 5x2 is positive 5x2. And then we'll have minus 1 times minus x is positive x. And minus 1 times minus 3 is positive 3. Now it's time to regroup it. So we have the highest exponent first. Just remember, when moving the term around, remember that the term's sign move with them. So we'll have minus 4x to the third power. Then we'll have 2x2 and 5x2 here. Both are positive, so we'll have positive 8x2. Then we have negative 5x and positive x. Then we'll have minus 4x. And the last one is negative 9. Let's do another example in subtraction, a polynomial. Let's say we have 3x2 minus 5x minus 6 minus 4x3 minus 5x2 plus 2x minus 3. We can simplify these polynomials the same as we did the previous one, that is, drop the parentheses, multiply this negative to the second polynomial and regroup them and then simplify it. This is one way. The second way is to line them up and subtract them as we do with the real number. The same as we did in the addition also. So we line them up. Then we'll have 3x2 minus 5x minus 6. As for the second polynomial, we need to multiply this negative to the polynomial. Then we'll have minus 4x3 minus 4x3 minus times minus 5x2 positive 5x2 minus times minus 2x, we'll have positive 2x, minus times minus 3 is positive 3. Now we can add them up. Just remember, we treat the power of the variables like place values when we line them up. For instance, if we didn't have x to the first power here, we would have left these places empty. Now let's add them up. Minus 6 plus 6 is minus 3. Minus 5x plus 2x is minus 3x. 3x2 and 5x2 equals to positive 8x2, and we bring down minus 4x3. So we simplified our polynomials, and this is the result. Let's multiply polynomials. Let's say we have 3x plus 5 times 3x minus 4. Multiplication is a bit harder because we have two operations going on, multiplication and addition. The polynomial is a sum of things, and we want to multiply two of these sums together. So we have to be more careful about getting rid of the parentheses because it involves changing the order of operation. So let's try this example. We are multiplying all the possible pairs where one factor comes from the first polynomial and it's going to be multiplied with the factors of the second polynomials. Therefore, we have 3x times 3x plus 3x times minus 4 plus. Then we have the second factor of the first polynomial, which is 5, multiplied by the factors of the second polynomial, which is 3x plus 5 times minus 4. 3x times 3x is 9x2 plus 3x times minus 4 minus 12x plus 5 times 3x is going to be 15x plus 5 times minus 4 minus 20. So we'll have 9x2 minus 12x plus 15x is going to be 3x minus 20. So we are done. We also can write it as 3x plus 5 times 3x minus 4. Minus 4 times 5 is minus 20. Minus 4 times 3x is minus 12x. Then we have the second term, 3x times 5 is going to be 15, positive 15x. 3x times 3x is going to be 9x2. Now we can add them up. We'll have minus 20 minus 12x plus 15x plus 3x, and we'll have 9x2. Same result. And we are done. Let's do another example in multiplication. x4 parentheses 2x minus 4x minus 5 close the square bracket plus 4 in parentheses. This is just an order of operation problem with a variable in it. If we work carefully from the inside out, paying careful attention to our minus sign, then we should be fine. So we start with 4x minus 5. Then we'll have x4 times 2x minus times 4x is minus 4x. Minus times minus 5 is going to be positive 5. Then we'll have our positive 4. We close the parentheses. The next step is taking care of the parentheses. So we'll have x minus 4 times 2x is minus 8x. Minus 4 times minus 4x is positive 16x. Minus 4 times positive 5 is minus 20. Minus 4 times positive 4 is minus 16. So we add them up. We'll have 9x minus 20 add to minus 16 is going to be plus 36. So we are done. A polynomial can be divided by another polynomial. We divide polynomials pretty much like we divide numbers. We have two ways of writing it. One in the form of a fraction, and the other to do it like long division of several place numbers. Let's start with a fraction. Let's say we have 16x6 minus 12x4 plus 4x squared over 4x squared. We can rewrite this fraction as 16x6 over 4x squared minus 12x4 over 4x squared plus 4x squared over 4x squared. Now we can simplify that. So 16 and 4 can be simplified as 4x, and we can subtract the exponent and we'll have 4 as exponent. 12 and 4 can be simplified and we'll have 3x2 plus 4x squared divided by 4x squared is 1. So we are done. This is a simplified fraction. We also can do it as long division. Actually, it's more common to divide polynomials using long division. Just as a reminder, when we have two numbers divided by each other, like we have 16 divided by 3, we can write it as long division, and divisor three goes as divisor to the outside notation and 16 goes to the inside notation, and this is dividend. Now, how many times 3 goes to 16? 5 times. 5 is quotient. So 5 times 3 is 15, and then we have remainder. So we divide polynomial just like this long division and treat the terms like digits. Divide, multiply, subtract, and bring down the numbers. Whatever it takes to divide polynomials. Let's divide two polynomials. X squared plus 3x minus 40 over x minus 5. The first thing we do is to make sure that the exponents are in a descending order, which are. Now, we are going to divide it as a long division. To do that, first we put down x minus 5 outside the division notation. Then we put x squared plus 3x minus 40 inside the notation. Now, we'll ask how many times x goes to x squared. X times. So we multiply x by x. X times x is x squared. X times minus 5 is minus 5x. Now we subtract it. Then we'll have x squared positive and negative. We'll have 0. These two cancel out. Then we'll have positive 3x minus 5x. It's like saying positive 3x and positive 5x. It's positive 8x. Then we bring down minus 40. Now we look at the leading term in here and we'll ask how many times x goes to 8x? The answer is 8 times. 8 times x is 8x. 8 times minus 5 is minus 40. We subtract them, and minus 8x plus 8x is 0. Minus 40 and plus 40, minus times minus is positive, minus 40 and plus 40 is also 0. So we don't have any remainder here. So in this case, x minus 5 goes evenly into x squared plus 3x minus 40 because we have no remainder. And that means x squared plus 3x minus 40 divided by x minus 5 is equal to x plus 8. Let's do another example. 6x squared plus 13x plus 8, 2x plus 1. The exponents are in descending order, so we don't have any problem there. We start to put down our long division. 2x plus 1 goes outside the division notation, and then we have 6x squared plus 13x plus 8 goes to inside the notation. Now we ask how many times 2x goes to 6x squared, and that is 3x. 3 times 2 is 6. X times x is x squared. 3x times 1 is positive 3x. We line them up and now we subtract them. 6x squared minus 6x squared is 0. 13x minus plus 3x minus times positive is negative, so we'll have plus 10x. Now we bring down our 8, we'll have positive 8 here. How many times 2x goes to 10x? Again, we look at the leading term and see how many times 2x goes to 10x. 5 times. 5 times 2x is 10x. 5 times positive 1 is positive 5. Now we can subtract it. We put a negative sign here. 10x minus 10x is 0. 8 minus 5 is positive 3. So we have a remainder of positive 3. So 6x squared plus 3x plus 8 divided by 2x plus 1 equals to 3x plus 5, which is here, plus the remainder over 2x plus 1. Now we are done. Let's do one more long division. 2x squared minus 30 over 3 plus x. As you see, the divisor is not a descending order. So when we start our long division, we correct that one and write it as x plus 3. Then we have our long division notation. The dividend goes under the notation. So we start with 2x squared. But as you see, we don't have a variable with x to the first power. When you have a missing variable or a term in a polynomial, we put a placeholder in the order. So we put plus 0x and then we put minus 30. Now we can divide it as usual. We start by asking how many times x goes to 2x2. That would be 2x. 2x times x is 2x2. 2x times 3 is going to be 6x. Now we subtract it. 2x squared minus 2x squared is 0. Minus 6x and 0x is minus 6x. Now we bring down our 30 and it will be minus 30. Now we look at our leading term here is minus 6x. Then we ask what times x gives us minus 6x. That would be minus 6. Minus 6 times x is minus 6x. Minus 6 times positive 3 is minus 18. Now we subtract them. We'll have 0 for the first term. Minus times minus 18 is positive, so we'll have minus 12. And this is our remainder. Now we reach to the end of our division. Since we have minus 12 as remainder, we can say 2x minus 30 divided by 3 plus x equals to 2x minus 6 minus 12 divided by x plus 3. And we are done. Now we reach at the end of our session on polynomials, how to add, subtract, multiply, and divide polynomials. I'm going to put some problems for you here to practice at home.